All right, let's go ahead and jump in. Thank you everyone for joining us today. We're excited to have you with us. Before we jump into the content, just wanted to go through a couple of housekeeping items. First off, this webinar is being recorded, so you can look for that recording as well as the deck to be sent to your email here in the next day or so. If you have any questions that come up throughout the session, feel free to put those in the Q&A of Zoom. We have some customer success engineers online today that can help out in answering those over Zoom, and then Steve will be able to answer some questions towards the end as well as time permits. And with that, we will pass it over to Steve.
Great, thank you, Taylor. I'm really excited to get a chance to share this content with everyone today. My name is Steve Graham. I'm a customer success engineer with GitLab Scale team. I've been with GitLab for close to 4 years now, and to be real frank, GitLab CI and CD were one of the primary motivations for me joining GitLab. I wanted the opportunity to really deep dive with everything tooling oriented from GitLab, and this role gave me that opportunity. We're going to be covering GitLab CI concepts with a very large list of advanced topics today. And just for awareness, that means we're going to have to go at a fairly good pace. So please do be looking out for the email from Taylor following the session that will have a link to the recording that you can watch, and you'll also be able to download this particular presentation set of slides, which is just absolutely filled with links. So our goal is to help you to understand a wide breadth of the potential variations that you may want to use in pipelines. So let's go ahead and kind of get next. So in addition to what Taylor was talking about a minute ago, we're going to be inviting you to participate in a hands-on workshop for CI. I really want to encourage you to join us if you can make the time. This is going to be a hands-on workshop. It's highly recommended for the experience and for the guided curriculum. You'll be provisioned with your own dedicated sandbox environment for the work. And by the way, that's going to be an ultimate group in one of our, that is a subgroup of one of our namespaces on GitLab.com. You're going to learn how to build simple GitLab pipelines and work up to more advanced pipeline structures and workflows, potentially including security scanning and compliance enforcement. Now, one of the things we're thinking about doing with this one, most of these hands-on workshops are provisioned for hours. We're actually thinking about making this one available for a day or two after the workshops, so that you have a little time to play and experiment and try different things you might want to try. You're also going to get an opportunity to engage with a GitLab customer success engineer. Myself, my peers that are on the call today, and a couple of other ones. We can all be consulted to advise how to get started, options you may want to consider, how your pipelines can be governed by settings in your projects. We can also help answer questions that may come up after today's session. So this is our agenda today. We're going to be covering CI and CD basics, which is just a quick review of what pipelines are, what they look like, the different elements involved in each. We're going to do a quick review of the pipeline structure file, the overview of the pipeline files. Then we're going to go through pipeline structure and different ways to hack that. Now, there's a lot of different variations for pipeline structure, so there's a lot of content there. We're also going to talk about variables, and then we're going to talk about rules, controlling when your jobs run, which often relies on variables, and then holding, securing, and sharing results with job artifacts, and then assembling pipelines from components, using includes to include separate files into your pipeline main file, and then using extends to extend jobs. For teams that need to get a quick leg up on CI and CD, we do have PS offerings for this. So just be aware that that is one of the things that you can do. And I'm not going to spend an incredible amount of time on the slide, but just know that we do have PS engagements for teams that need to get moving quickly. Now, let's take a quick minute for a poll. We're interested in understanding what may be holding you back from using CI and CD right now. Taylor? Yeah, thank you, Taylor. Okay. Yeah. Let's start talking about GitLab CI and CD basics. This is just a review of what some of the concepts, what it looks like in GitLab. Let's start with GitLab Flow. GitLab Flow is the recommended workflow for branching, merging things back into a protected branch, default branch, main, master, whatever that might be for you and your team. Variations on this are Git workflow, GitHub workflow, all of which, by the way, are supported within GitLab. This is the one that we recommend based on experience and iteration with our customers. So essentially, you go through some type of planning, epics, milestones, issues. Once that's been assigned to somebody to work on, they create a merge request, and then immediately they start iterating on that merge request or the branch, right? So when they create that merge request in GitLab, it gives them the option to create a branch automatically, and it'll give it a very random name that'll make sense to you when you're looking at it. But it is a very random name so that it doesn't conflict with any other branches in the repository. And then when you're done working on that, you're going to create a merge request to bring it back in. Well, in this particular case, we create the merge request in advance, the branch is there, and then we start to iterate on the code. And during the iteration of that code, we're going to have these pipelines running in this section right in here. They're going to automate the build and the test, scan for vulnerabilities. We're going to collaborate and review. And it may be necessary at that point for us to go back, make additional changes to the code, and then rerun those same pipelines again so that we can go through that same process again. When we feel like we've got a satisfactory result, we might want to launch a review app so that people can go in, do user acceptance testing in person themselves, make sure that it's exactly what they need it to be, apply approvals to it. And then at that point, we would be merging the merge request back into the protected branch and creating a release from that and maybe deploying from there. So this is kind of a picture of what GitLab CI and CD is conceptually. We've got the code, the commit, any related code that goes along with it. We've got the pipeline in there that's going to do the build, the unit tests, integration tests, scans for vulnerabilities, things along those lines. We might want to create a package there if we've got something that's released as a package. And then we can launch a review app so that we can go look at it. This is a specialized, environment that has our production, what we anticipate being our production code on that release branch, on that release environment, so that we can actually take a look at it. Maybe move it to a staging environment and then release it on production. Okay, so if we talk about the anatomy of a GitLab CI and CD build, the pipeline is everything all together. It's a set of one or more jobs, optionally organized into stages, which is ideal. Stages are collections of jobs that run in parallel. We might have build, test, and deploy. And then jobs are scripts that perform individual tasks. This can be npm test, nvm, mvn install, things along those lines. And, they might include things like deploying apps. So where we deploy, this could be on an environment. A job can include an environment as a keyword inside the job itself. We might deploy to test, review, staging, canary, prod, just whatever makes sense for us. Now, I just want to make everybody aware that this is a list of the security scanners that are available in a premium subscription. So if you have premium, these are some scans that you should definitely be leaning into and enabling in your GitLab CI and CD. This is a longer list, of course, of what's available in Ultimate. It essentially comprises a complete list of security scans that you can use against your code. Also, notice that each one of these is a link you can follow to our documentation for. So just remember that when you download the slides. So let's talk real quickly about GitLab CI and CD, the pipeline file itself. GitLab's robust support for CI and CD over an extended period of time has resulted in very, very mature pipelines that are well equipped to handle an extraordinarily diverse range of scenarios. Getting started with pipelines is easy. They can be effortlessly expanded and customized to meet your specific needs. And GitLab offers the flexibility to define multiple pipelines per project that can be mutually exclusive if you choose, enabling you to address any scenario that requires an independent pipeline in your project. So if we look at a GitLab, .gitlab-ci.yml file, or whatever you choose to name that file in your project, the first thing it's going to start with is the section that we call globals. GitLab YML files are declarative. You're not taking on a new programming language to learn these. It's like filling in an INI file that has arrays and everything else attached to it with keywords. It uses the global keywords in the global section. Image in this case, the thing you see at the very top up here is setting the default image for anything that uses a Docker container thereafter. Now, that could also be put into the default section here if we chose to. So globals are going to define defaults for jobs, which is what this default section is here. Sorry, went too far. It allows us to set variables, and you can see one being set there. We can declare stages, and we really should if we want to have control over what those stages are. And then we can define workflow rules, which are not shown here, but workflow rules are just conditions under which we're either going to run a pipeline or we're definitely not going to run a pipeline, because you can have rules that are positive or negative, either one of those two. So this is an overview of GitLab jobs, right? So this is jobs in a pipeline. Jobs can be hidden, and that just means they start with a period. Hidden jobs are used as templates for downstream jobs. They're never instantiated as a job themselves if they're hidden. The script section on a job, this section right here, is absolutely required. So you have to have that or your YML won't be valid. You can use rules, which you can see here. It's a very simple rule. And it needs to declare the stage that it's going to be running in. And there's a lot more options that we're going to cover in more detail today. Now, I'm not going to spend a lot of time on this because we've got a slide that covers this, but there's a lot of different ways that you can include files from your own project. If that local up there is a keyword that means, to look for this particular named file in the repository that you're running on. You can use template files, which are shipped with GitLab and come in a whole wide variety of capabilities, like all of the scanning capabilities that we can do. You can include files from other repositories in GitLab. You can even include files from HTTP or HTTPS URLs if they don't require authentication. That's real important because there's no way to authenticate. And these can use rules. As you can see, I'm using rules on this particular one here today. So let's take another quick minute for another poll. We're interested in understanding what other tools are being used for CI and CD. Great. So let's move into pipeline architectures. This is the various ways that you can construct a pipeline. It's really up to you. Oops, sorry. Building blocks of your pipeline, think of it as we've got a basic pipeline, which is just a very simple pipeline. We can use directed acyclic graphs to create relationships between jobs so that we know what dependencies are in line and when a job should be a candidate to run. We have the ability to create parent-child pipelines so that when a pipeline is running in your project, you can spawn an independent pipeline in your project to do something else without having to, for example, wait for your pipeline to finish or wait for that other pipeline to finish for your pipeline to be able to get all the way to the end. We have dynamic child pipelines, which is the ability for you actually, if you need to create some decision criteria in your job itself. And based on what you're seeing in the code, be able to create custom YML that runs jobs according to whatever rule set you want to do inside your job. And then we have multi-project pipelines, which is a very popular feature with large monorepos that have been busted up into their components. So you can actually spawn a pipeline in another project if you need to. Now, basic pipelines, these are the simplest pipeline in GitLab. Jobs run independently, sometimes on different runners. All jobs in the stage must complete successfully before proceeding to the next stage. And you can control pipelines with pipeline options. So this is an example. This is a real simple example of a pipeline here. And what you see in the vertical columns are the stages. So when we talk about stages, that's exactly what it is. That's just a collection of jobs that run in parallel, subject to the availability of runners. The important thing to realize about this is a few different things. This particular job right here, this test B, has an exclamation point. The reason why is because this job has allow failure to be true in the job definition itself. And as a result, it can fail without stopping the pipeline. So it doesn't give you the error message that would be there if you allow failure equals false. So it just gives you a way to be able to see the test results without having to fail the pipeline for whatever reason you need to. And then notice that the deploy job has a play button on it. This is using a when clause of manual. And what that means is that you can control when that particular job runs by going in and just clicking play on it. And if you're using protected branches, you can also determine who's allowed to click play on it. The same is true of protected environments. So just be aware, those things are possible to do. And then some of the other when options that are popular is delayed. We can use a when delayed, and we can launch it in 15 minutes. We can launch it in 3 hours, whenever we choose to. When on failure is used for conditions where something's gone wrong with the pipeline, something's failed. Now it's time to go back in and either do some cleanup, remove some things from different places in GitLab that are appropriate, just whatever you need to do when a pipeline fails. It might even be just notify people that a pipeline failed. And then when always is going to run unconditionally, no matter what, whenever it comes up. So next, let's talk about directed acyclic graph. And I think most of you are aware of what this is, but this is just a way for us to create dependencies and relationships between jobs. It defines job dependencies to optimize your pipeline flow. Jobs, still run independently, sometimes on different runners, but dependent jobs could proceed to the next stage without waiting for the jobs in the stage previous to that job to finish. So if you've got jobs in test and then some test job finishes and you've got jobs listed in the next stage, as soon as the job finishes that is a requirement or a dependency for this job you've got in this next stage, that next job can fire up without waiting for all the rest of the previous jobs to go. Now, here's a real good example of this. In this particular project, there's a build for Android, a build for iOS, but no reason for those two tests to have to wait for both to finish. And in this particular case, you can see that test for Android is dependent upon build for Android. And as soon as build for Android is done, it doesn't wait for build iOS to finish. It just goes ahead and fires up. So the job still runs in stages, but the needs keyword overrides the need for the previous stage to complete entirely. It's eligible to run as soon as the previous job that it's dependent upon is complete. Now, the other thing that's kind of cool about this is you get a directed acyclic graph. And if you go to the CI/CD pipelines page and you pick a pipeline to examine so that you can see its job list and its stages, One of the options at the very top is you've got a needs tab. If you go to the needs tab, you're going to get this directed to cyclic graph, and it's going to show the relationships between all jobs. So this is handy for making sure that you've defined all of the appropriate dependencies that you need to. Now, next, I want to talk about parent-child pipelines. So remember that parent-child pipelines are launching pipelines in the same project, but it's an independent pipeline. And you know, the degree of independence or dependency is up to you to specify in your job, in your bridge job, or in the jobs downstream. So you can run child pipelines independent from each other. It separates the entire pipeline configuration into multiple files to keep things, you know, simple for you, which is to say that you can have independently defined .yml pipeline files that are just for these child pipelines and don't ever get included in the main GitLab, you know, .gitlab-ci.yml file. And it's useful to branch out things like long-running tasks in separate pipelines. Now, if we look at a pipeline that has this parent-child on it, what we're going to see is we've got these downstream pipelines that are happening, and clicking on any one of these will expose, you know, either the status of the downstream pipeline or the independent jobs, depending on how you defined it. So, so what does that look like? In the job itself, we can see that this build one job right here is going to trigger an independent pipeline. In this particular case, we're using only instead of rules, and it's triggered on changes. So it's going to look for changes in this particular path right here. And if it finds any of them in the commit that we're running on, it's going to go ahead and launch this independent pipeline. And then this trigger is the keyword that lets you launch a downstream pipeline. And what you can see here for include is it's going to include this file that's specified here in the project. And strategy depend is an interesting thing, because depend allows you to create a scenario where the downstream pipeline has to finish for your upstream pipeline to be successful. If you use depend, that's the case. If you don't use depend, that pipeline downstream is completely independent, and whether it is successful in its completion or not has no impact on the upstream pipeline. Now, the other thing it does is that strategy depend exposes the jobs from the downstream pipeline in the upstream pipeline, so that when you click on that trigger job, you'll be able to see the jobs in the downstream pipeline. So dynamic pipelines are a different concept, and the general thought is, you know, you're going to run some test or evaluate something that's happening in the project in the context of one of your jobs, and then you're going to use that to create an independent pipeline. It's a dynamic child pipeline, and it's going to happen in a later stage in a separate job. So this is useful to use a single pipeline configuration with different settings to support a matrix of scenarios, depending on, you know, what it is that you need to make decisions about and what conditions you'd want to launch a child pipeline for. So dynamic pipelines look like this, and you can see that this setup job right here is set to leave an artifact, and the path is generated config.yml. And then this test stage is going to declare that as an artifact that it needs to be able to use to run. And this is the trigger of the bridge job. So the setup creates the generated YAML file. Downstream job is the trigger job that's going to launch the downstream pipeline. And that's going to be in the same project again, but it's going to use this artifact file so that you can generate that dynamically if you think that's appropriate to do. So the next concept is multi-project pipelines. And this is, as it sounds like, I can launch a project, I can launch a pipeline in a project that's in another location on the same GitLab instance that I'm on. So a pipeline in one project can trigger a pipeline in another project. So an important note about this is any user who can trigger a pipeline will need to have the right role to trigger a pipeline in the downstream project. So they've got to be at least a developer in your project to run a pipeline, and in that downstream project, the same thing is true. They're going to have to be at least a developer. You can specify a branch in that downstream pipeline if you need to, and you can pass variables to the downstream pipeline. And if the downstream pipeline fails, it will not fail the upstream pipeline. Again, that relies upon that depends keyword. And then useful when building and deploying large applications that are made of different components. And where I see it a lot is in projects that used to be large monorepos that have been broken out into the individual components. Now, every time one of those individual components creates a new version, it'll launch a pipeline in the upstream aggregation project that's going to pull everything in for the build and allows that pipeline to take place. So let's look at a few different things here. This is one way to pass a variable downstream by declaring the variable in the job itself into the variable keyword. Another option is to use this forward in pipeline variables. Use that to define what you want to pass forward. You can specify the project and the branch right here. See under the trigger job, we're specifying the project. The path from the path to the project is from the root of your local GitLab instance. If that's GitLab.com, it's going to be some root level namespace followed by a project. And then you can specify the branch that you want to use in that downstream project. And then again, you can use this strategy depends. Remember that exposes the jobs in the upstream pipelines if you need to be able to see that, but it also creates a dependency between the two so that so that the upstream pipeline isn't considered successful unless the downstream pipeline is able to pass. Now, the job with the trigger keyword is often referred to as a bridge job, but it doesn't have to have this name. You can have any name you want it to have. And then the downstream pipeline can be anything you choose. So it's because it's not running that downstream pipeline's specified .gitlab-ci.yml. It could if you want it to. But the presumption here is that if that downstream job is going to have some special pipeline definition that's just for this kind of use, and you can use any pipeline name that you want to use, any pipeline file that you want to use. All right, so let's talk a little bit about variables. Variables become very important when you start to use rules. GitLab pop predefines an extraordinarily long list of variables that you can use to define your rules with, learn things about your pipeline. And so let's dive into what those are and how you can set them up. You can set your own variables in GitLab. You can do it at the project level. You can also do it at the group or the instance level if you're self-hosted. So, this is under settings, CI and CD, and then you expand the variables. And once you expand it, you'll see the ability is there for you to be able to add a key name and a value right there. Now, there's some other options available there too. You'll be able to hide that or mask it so that people can't echo it out if you don't want that to happen in your pipelines. Now, realize that GitLab has a regex mask that they have to, that variable's value has to be able to pass in order for that to work. But you can try it there and then try and hide it. And if it's not able to hide it for one reason or another, it will make you aware of that. But be aware that some of the other settings available for these variables are you can make them protected. And if you make them protected, they're only going to be exposed to protected branches. Feature branches won't ever see these variables. Variables can be entered in the pipeline run page. So if you go to CI and CD, the default page, it's the pipelines page with the list of pipelines. And at the very top, you'll see this run pipelines button, run pipeline button, and it's going to expose a form where you can create new variables right there if you want to do it. You just have to define the key and you have to define the value, but you can also expose variables there and give people an understanding of what that variable is meant to control and what its potential options might need to be in a description using the right syntax in your YML file. You can also define variables in your CI configuration. So this is a global variable here. This is outside of a job. And it could just be this keyword variables. And you can define the names, the key names and the values you want them to be. But you can also define them inside of a build job. I'm sorry, inside of a job. So this is a job called build. And it's defining variables and it's defining this environment staging. And if we were to echo this out, trying global var, the one defined up here, on environment, the one defined here, that would absolutely work. You'd be able to have access to both. Now you can also inherit variables. Now the idea behind this is you've run a job, you've made some decisions during the course of that job. You want a downstream job to know about that. You can leave a .env file. It can be any name you want. It's just got to be .env as an artifact. And artifacts by default get downloaded on all downstream jobs from the point that they're created. So every single job that is downstream of this job will be able to grab this build.env file that has this single value defined in it, single variable defined in it. And if we look at this and we define it here in this next job that's going to use this build.env file, remember it's going to pass that automatically. So in this deploy job, we define build variable the same as we've defined up here, and we give it value from deploy job versus value from build job. And we go to echo it out. What we're going to find out is that this build.env has precedence over this definition here. So these artifact files that are set up as .env files take precedence, but, and this is really important, they're not accessible for rules or anything outside the script section of a job. So as soon as the script section fires up and evaluates that, then at that point, you have access to the variables, but they're not going to be accessible to a rule for the downstream job. Now, if we talk about variable precedence, the general order here is from bottom to top, top wins. So the values from GitLab, which is predefined variables, stuff that we set up, which, by the way, I probably wouldn't want to change if I were you, because it's important that you know what those were. If I needed variables to hold things, I would tend to use ones that I had defined myself. Then you've got the values that are set in the YAML file that you create yourself or any of its includes. And then you've got the values that are inherited from previous jobs, previous stages. Then you have values configured in the project grouper instance. And then if you're running this manually in the UI, from the pipelines page in that run pipeline button, or an API request or a scheduled job, you can, every single one of those allows you to set the variables that you want to be set for that specific run, and those take the highest precedence. And then that applies to both the CI engine and the main GitLab server where rules are evaluated. It also applies to CI jobs on the GitLab runners. So let's take a little bit of time and dive into rules. Rules are easily one of the most valuable parts of building GitLab pipelines, and they're relatively straightforward and easy to understand, which is not to say that you won't stub your toes once in a while or have to hop over something that gets in your way, but they're relatively easy to use. And it's important to understand first when our pipelines run at GitLab. So any new commit, any new branch you create, any new tag you create, a merge request that you create. And by the way, a merge request comes from a source branch. So understand that when you open a merge request, if you have to iterate and make changes to the code, you're going to get new pipelines every single time that you put a new commit into that source branch in the context of that merge request. You can also launch them manually from the pipelines page using the run pipeline button. You can also use an API call if you want to, and you can set up a scheduled job that runs maybe nightly if you need to. And I see teams doing this to check the latest state of their dependencies, containers, run their security scans against stuff like that to make sure that whatever's out in production right now is still good and hasn't got any new vulnerabilities that they need to be paying attention to. So the basics on rules, we've got a job name here, which by the way is anything that's not a defined keyword in GitLab. That's not a defined global keyword in GitLab. It's an arbitrary name you just set yourself, whatever you need it to be. And then there's a keyword under jobs called rules. And if we use rules, rules is an array, and each array element starts with this dash right here. So every single dash is a different condition rule. GitLab's going to go through these rules from top to bottom. First match wins. And as soon as it finds a match, it's not going to process whatever comes after it. So in this particular case, we're saying that if the CI pipeline source equals web, that's a predefined variable, by the way, equals web, which is the CI and CD default page and run pipeline button. Then this script is going to run. Now, the thing to realize about this, this particular job and this rule is that this rule has an implied when on success. So it has an implied in the same array element right below the if. If you were to type in when colon and some value, you could override what the default is. And the default is when on success, which means everything before this job was successful or was allowed to fail. And then this job is only going to run from the web form. That's the only condition it's got here. If we were to put a new dash right here and put a standalone when clause that said when colon always or when colon on success, then it would run in just about any circumstance at all. So let's talk real quickly about some of the various elements of a rule. You have clauses, if changes. So changes is going to look for changes on a path in the repository itself. If it finds them in the context of the commit or the merge request, then it's going to use it. It's going to, that rule is now true. And then exists is very similar, except that it's not looking for changes. It just wants to know if that particular file exists or that particular directory. And then the operators are what you would normally expect them to be, the equals, the not equals. Note that these two right here with the tildes are used for regular expressions. And the regular expressions in GitLab work exactly like you would expect them to, given that we use slash delimiters, but everything works exactly like you would expect it to, and like I've been accustomed to in every single past role before coming to GitLab, using regular expressions. And then the two at the bottom are just, you want to join together a couple of different tests with the end, you can do it. The or just lets you do exactly what you think it is. You can this condition or this condition kind of scenario. And then the results can be set up by, when, which has all of its options listed on the right there. Always, never, on success, on failure, manual, or delayed. That's the various forms that when takes. Allow failure can be true or false. And again, if it's true, that job's allowed to fail and it won't stop the pipeline. And then results start in is just, we want to start 15 minutes from the point that the job is eligible to run, right? So this is not from when the pipeline starts, but when that job is eligible to run, start in 15 minutes, start in 3 hours. You can pick whatever increment makes sense for you. All right, so in this particular rule, we can see that we've got two rules, two dashes, right? Two independent rules. If CI pipeline source equals merge request event, and there's no delineated when for that rule, so it defaults to when on success. So if this is a merge request event, this job's going to run. If this CI pipeline source equals push, so somebody committed something into any branch on the whole repository, because this doesn't delineate branch, it just delineates the type of event. If it's a push, then it's going to run this job as well. Now realize that you can do if CI pipeline source equals push, and then test for a merge request event, do an end-to-end, and then test for a merge request event right after that. And then you would only get a push on a merge request event. So just keep thinking about that. And then in this rules example number 2, this pipeline is not going to run if this was triggered from a merge request event. So notice that this has got the standalone, it's got the when clause included in the context of each rule that's been defined here, but it also has a standalone when here at the bottom that has no rule at all. So in that particular case, since there's no rule, if the two rules above it don't match, then that is going to match unconditionally. So first rule is if CI pipeline source is a merge request event, we don't want this particular job to run. So this is a negative rule here. And then the next one is if CI pipeline source equals schedule, we don't want this job to run. Now remember, the first match wins, and as soon as it finds a match, it stops processing rules. But if it doesn't get, if neither one of those is successful in matching on the event, then we're going to default to win on success and run unconditionally there as long as everything that ran before this job was successful. All right, so this job will be in the pipeline. It's going to be a manual job. So notice that it's got a when manual down here in the context of this rule. So this rule, we've got one array element here. However, changes defines its own array here. So we're going to be looking for changes in Dockerfile or changes in Docker/scripts, anything in that directory. And if this rule matches, it's going to be a manual job, which means it's going to have a play button on it that somebody can be authorized to click on if it's on an environment or if it's on a protected branch. So this job in the pipeline is going to be a manual job. We can set it up to, in fact, it is if var equals some string value. So we're testing one of the predefined variables against some string value. Maybe it's, we're testing that the branch name is main or master or something along those lines. And then if there's changes in the Docker file or changes in the scripts for the Docker file, we're going to have a manual job. And notice that there's nothing else in this rule block, nothing else to match against. So if this rule doesn't match, this job isn't going to run at all. It doesn't have another rule to default to. Okay, similar scenario here. CI commit branch equals main, which is what I was just talking about a minute ago. In this particular case, if this matches, this job is going to start. It's going to, when delayed, it's going to have a start in 3 hours and allow failure if true. So this is going to wait 3 hours to run from the point that the job is eligible to run. And then it's allowed to fail. So it's not going to impact the pipeline status regardless of outcome. Now this is a special use case. This is actually global. So remember in the very beginning, we were talking about the elements of a .gitlab-ci.yml file. And one of the first things I talked about was global elements. These are outside of a job. Workflow rules are decisions, bool decisions that you can make at the very beginning of this file to decide if I'm going to run a pipeline at all. And even if you've got rules that match downstream in your jobs, you can decide that you don't want to run a pipeline under certain conditions, or you can decide to run it under specific conditions. It's just up to you. And this particular one is not going to run if there's a C. Now, I want you to notice that it's using regular expressions here in this in this operator. It's looking for a -WIP at the very end of the commit message. It's got to be the last part of the commit message. And if it finds that, it's actually a space -WIP, but if it finds that, then it's never going to run a pipeline. Remember that when never means it's a negative match. And if it's a CI commit tag, right? So if somebody just created a tag, we're not going to run for that either. In all other conditions, our default is going to be unconditionally always. No rule, just unconditionally. If those first two rules don't match, now I'm always going to run no matter what. Now, this is an example of variables that are depending on something. The variable Docker file is going to be set differently based on the rules. And as you can see here, we're defining variables in the context of an if statement. One of the things that you're allowed to define for a rule, this is inside the workflow rules. If CI commit ref name has the -WIP at the very end, then the variable is to use this test Docker file as your Docker file. But if the CI commit ref name equals the CI default branch, presumably main, master, whatever that might be, but this is a cool way to not have to put code in the name of your branch that you're using as your default branch. You're just testing the ref name against the CI default branch name, which is in the project settings. In that case, you're going to use main.docker file. And notice that neither one of these has a when defined, so the when is on success for both of these by default. So it's going to be set differently. The Docker file is going to be set differently based on the rules. And this pipeline is always going to run. There's nothing in here that's a negative rule. There's nothing in here that's stopping the pipeline from running. The only thing that's varying is that Docker file variable based on, whether or not that -WIP is there or whether or not it's coming into the default branch. All right, now let's talk about artifacts a little bit. GitLab jobs have the ability to generate these artifacts as you would expect in CI or CD. They have the ability to generate artifacts, and as long as they declare them, GitLab's going to upload them back up to GitLab automatically for them. And then again, by default, those are going to pass to every subsequent job after the job that defines the artifacts. So here's some examples here. This allows for saving of build artifacts and or the output of a job. They're available for use by any subsequent job. The default is that they automatically get downloaded to subsequent jobs. And by the way, that's a tip for potentially increasing the efficiency of your pipelines, which is that there are ways to tell it not to download these files if a job is not dependent on any of these artifacts. You can pull in any combination of paths or files that you need to be uploaded back to GitLab. You can use exclude to limit what's needed. And then in downstream jobs, you can use needs::artifacts, which is a subproperty of the needs keyword, or you can use dependencies. And in either one of those cases, if you put it in an empty array, nothing is going to get downloaded to those subsequent jobs at all. But you can also delimit what you want to be downloaded there as well. You can use when to determine if if artifacts will be stored or not. In this case, you can see it's when on success. So if this job is not successful, it's not going to upload its artifacts at all. Jonathan, let me take a quick minute here. The best thing to do on that, Jonathan. So the question is, you mentioned multiple mutually exclusive pipelines in a single project. What's the best practice to achieve this? And is there a good way to label or distinguish the different pipelines types? On the web pipelines page in web UI, yes, there absolutely is. So the way to think about this, I'll tell you what I'd like to do. Let me just share something with you. This is where I'm testing mutually exclusive pipelines. I just keep this open in case I have to come here for any reason. And what you can see is that the pipelines, these two jobs, these two files up here at the top don't do anything that creates a pipeline at all. They define the jobs, they define the rules, but the jobs have a default rule that won't run at all. But when they get included in any of these subsequent pipeline files, they get rules automatically that will run based on these same types of rules that you're seeing here. This is what I personally like to do. And one thing that you can do that's really valuable here. Now, this particular project has one pipeline you can run where you can manually select all the jobs you want to be in that pipeline by pre-populating a specific variable. And it's called job selections. And they can put in a space or comma delimited list of all the jobs from the all jobs.yml file that they want to be able to include it in that pipeline. And so this way I can put the description up there and tell them what it is that needs to be in there. But be aware that if you need a scenario where that job selection is needed to just have one value, not multiple, like I'm trying to do here, there's actually a way for you to pre-populate a form. It will have a list of all the various options that they can pick if they want to. And once they pick one, but it's a pick one only type of form. Once they pick one, that becomes the value for that particular one. So there is a way to do that. Sorry, I got really sidetracked there. You got me up on one of my personal pet peeves. All right, so if we want to download artifacts, we can do it very easily from the artifacts download capabilities in the UI. If we go to the pipelines page, which is the default CI and CD page, you know, every single pipeline that's shown there is going to have the ability to download all the artifacts for that pipeline if you want to do that. The same thing's true on the jobs page, except you can download all the artifacts for a job. And then on a specific job, if you click through to the job, and for example, you now have the ability to look at the job log, see the output of all the commands. You have the ability to download the artifacts if you want to, or you can go into the artifact browser by using this browse button right here. If you do that, now here's the important thing to realize: GitLab's going to tar up these files. It's going to tar them up for the pipeline. It's going to tar them up for each individual job. But if you use this pipeline explorer here under the individual job, you have the ability to open that. GitLab's going to open that artifact file for you and give you the option to download any specific parts of it that you want to. All right, so artifact administration, self-managed GitLab instance. You know, Java artifacts can be stored in local storage, block storage, or they can put in object storage. It's really up to you. A lot of people like to use object storage because it doesn't impact the capacity levels of their local block storage, and they can change that block level storage in S3, for example, anytime they want to. They can expand it. Artifact expiration can be set and configured at the instance level, but it can also be set in the jobs themselves. So just be aware that, you know, we can set an expires in property for artifacts. We can make that 3 months. And that's really a good form to do if you're running on GitLab.com to help keep things under control. Now, the last point here is that artifacts fall under GitLab's access control, which means GitLab's authentication is running in front of artifacts. Unless you know, if you make the artifacts public for one reason or another, you know, GitLab's not going to try and get in front of it with any kind of authentication. But if you don't, if they're private or they're internal, or they're part of a private job or part of an internal, private project or internal project, the authentication is going to be right out in front. So these are not just static files sitting behind Nginx. Now, we have a lot of different places to store artifacts. We have a container repository. We have several package repositories. We also have a dependency proxy, and that's important to understand. So if you need to pull container images from GitHub, from, what's the word I'm looking for? Yeah, from the container repository we all like to use. GitLab will proxy cache those for you. So if you're using GitLab's proxy cache and it's turned on by default at GitLab.com, it's going to cache the latest versions of anything pulled down from that main hub. Now we have special language specific package registries here, and if you need to build packages for any reason or another, I would encourage you to follow this link and go and read our documentation about it. Now, the last thing I want to talk about here is dependencies. It's almost the last thing. I'm going to make this as quick as I can. Just know that this is a way to limit jobs coming into your downstream jobs after an artifact has been created. Notice that test OSX is dependent upon build OSX, which is going to make sure that that's the only thing it gets. So, and then test Linux is the same kind of thing. Now, if we were to create this dependencies keyword and give it an empty array, that would mean don't download anything. And that's a really good way to speed up jobs that follow jobs that create dependencies. Now, this last section that we're going to talk about, I'm going to make this as quick as I can, is it includes and extends, which are just ways of reusing code over and over again if you need to. So includes, just be aware, you can include from the local project itself. You can include from a project, another project on the same GitLab instance, whether it's gitlab.com or you're self-hosted. You can include projects from remote URLs, which HTTPS, HTTP, either one of those, but they must be publicly accessible because there's no authentication methods for that. And then you can also include templates, and templates are just GitLab CI files that typically contain jobs, although there's a case of a workflow in our auto DevOps file that are just shipped with GitLab. So this keyword template here means that they were shipped with GitLab. And there's a whole list of those available for you. That one of the list of the scanning pages that I went through at the very beginning has links that'll tell you how to go about using these. And then GitLab has the ability to extend jobs. One real good example is this dot at the beginning here. This is creating what we call a hidden job, which you can think of as an instantiable class, whatever you want to call it, that you can then extend by using this extends keyword. Now, you're not limited to extending hidden jobs. You can also extend normal jobs that you declare and just overwrite the parts of them that you need to, if you need to. Now, this is an alternative to YML anchors, which quite frankly work pretty well, but can look fairly complex. It's a little more flexible, and you have the ability, you can do multiple extends. And one of the things I like to do is I'll put rules and do a list of jobs, and I'll declare the job that has the rule that I want to have here. And then I'll use patterns for the type of job that I'm going to run. You know, if it's a build job, it's going to have some common build commands, things along those lines. And if I need to override anything, I can. But you can do multiple extends on the same line if you need to. You can also do continuous inheritance if for some reason you need to do that. So job 1 is extended by job 2, which is extended by job 3, and that's the inheritance we're talking about. So it's not this case of just delineating what we're going to extend. And we can use includes and extends together. So we can include a template file. The template file, I'm sorry, we can include this included.yml file. It's defining a hidden job called template. And then we can use the template by this extend statement under use template. So in the end, that use template job, which doesn't have its script defined, it's defined in the what it's extending. And remember, script is required for jobs. It's just going to echo out hello. But the point being that you can combine these two together to get to the best combination of whatever works best for you. Taylor, I'm so sorry I've run us all the way to the end.
No worries. You were able to answer some questions throughout. So I didn't see any other come through. So I think we're good.
Okay.
With that, we'll wrap up. Thanks, everybody, for joining us today. As we mentioned, we will be following up with an email with some key resources, the deck, the recording, obviously, and then also some opportunities for you to sign up for that hands-on workshop. next week, as well as a one-on-one meeting either with Steve or another member of the customer success engineering team. And we're looking forward to that and engaging with you in other ways. Thanks everyone for joining us today.
Thank you.